Okay, well, I think it's been a couple of minutes. At least we're 3 minutes past the time that we scheduled. So why don't we go ahead and get started? So, hey everyone, today we're going to talk about how to crush the MCAT Chem Phys section. I'm sorry, not the car section. There was a typo here, which I can obviously correct. But I was informed at least that your group wanted to talk about the Chem Phys section. Although I am going to say that because this is a small group, we can be pretty casual. So if people want to talk about cars or any other sections, I'm happy to do that as well. I guess maybe what would be helpful for me is to get some information about the people that are here. So I guess in the chat box, for those of you who are going to be taking the MCAT soon, if maybe you can just enter in when you're planning on taking the exam, that'd be a little helpful for me. August 14th, January 21. Okay, so pretty good. So someone is taking the exam very, very soon. So hopefully you've been doing lots of studying. But it seems like most of you are looking at January, which is fine. It's a good time to start thinking about the MCAT. All right, well, in that case, let's just go ahead and jump in. This will probably be the most relevant for Kevin. And I guess since most of you are looking to take the MCAT, I'm guessing you probably all have a pretty good idea of what the MCAT is. So I guess this slide is just introducing me. So my name is Ken, and I oversee all aspects of MedSchoolCoach's MCAT program. Before I came to MedSchoolCoach to start an MCAT program, I was a senior MCAT instructor, premier tutor, instructor trainer and core content developer for the Princeton Review for about 5 years. So essentially, I've been in this MCAT space for a very long time. The plan for today is to talk a bit about the unique format of the MCAT. This is usually to catch everyone up so everyone knows what the MCAT is about. Then to focus a bit about Chem Phys, this section, possibly go through a sample passage and then spend the rest of the session answering any questions that anyone has. But like I said, again, we have a small group today, so it can be fairly casual. So if there's anything that you guys want to discuss today, happy to do so. All right, so real quick, the MCAT has 4 sections: Chem Phys, Cars, Biochem, and Psych Soc. The 3 science sections are 95 minutes each. The Cars section is 90 minutes. If you include all the breaks, you're looking at a 7.5-hour exam. And next, we can talk about scoring. So each section of the exam is scored between 118 to 132. 125 right in the middle is the average score, 118 obviously being the lowest score, 132 being the highest score. The nice thing about this is it's very convenient for medical schools, because if a student gets an average score in all 4 sections of the exam, then we're looking at a 500. So this makes it very easy for medical school admissions committees to identify if a student is above average, meaning that their score is in the 500s, or if they are below average, meaning that their MCAT score is in the 400s. The MCAT is scored on a normal distribution, so that means most students are going to be right in the middle, around a 500, and very few students are going to be getting a very high score, and very few students are going to be getting a very low score. Next, in terms of the format of the exam, it is a complete multiple choice test, and that means there's no free response whatsoever. Every question is worth the same amount of points, so there's no benefit to spending more time on one type of question versus another. And notably, there is no guessing penalty, so you never want to leave any question blank on the exam. Something I want to emphasize is, while it's a multiple choice test, it has a combination of passage-based questions and freestanding questions. Freestanding questions tend to be a little bit easier because they're just based on science content that students are expected to have memorized for the exam. The passage-based questions are more difficult, and that's because for these questions, the MCAT will have passages that will introduce new situations, new information that students have never seen it before, and they're expected to apply their knowledge of science to those passages to get the answers. So this is part of what makes the MCAT a difficult exam. The next thing we can talk about is test dates. So for those of you who are planning on taking in January, you've already done a good amount of thinking and probably already know that the MCAT is offered in January. It's also offered in the months of March through September, and for each test date or for each month that the MCAT is offered, there are multiple test dates. And something just to keep in mind is for those of you who are looking to register for the exam soon, just make sure you register early so you can get your desired test date and testing center. Some of you who are testing this summer probably know sort of the chaos that happened a few months ago when the AMC opened registration for summer test dates, and there were 62,000 students who tried to register on the same day, and obviously the AMC website crashed immediately. It's not great for the AMC, but it's kind of an annual thing that happens. For those of you who are wondering when registration is going to open for 2021 test dates, there are 2 rounds of registration. The first round of registration opens around mid-October. This is for spring 2021 test dates. For those of you who are planning on taking the MCAT next summer, 2021, registration for those test dates will open in February. All right, so hopefully that gives you some idea of the general format of the exam. Another related question that we get is sort of the different sections of the exam and more details, right? Now, for this presentation, we're going to focus more on the Chem Phys section. If you notice, sort of in my original slide, it was on Chem Phys and Cars, and that's because the Chem Phys section and the Cars section are the 2 sections that students typically have the most difficulties with. Cars is kind of just a beast of its own. The Chem Phys is one of the 3 science sections, and while it's just one of the 3 science sections, there's actually a variety of reasons why the Chem Phys section is more difficult for many students than the other 2 science sections of the exam. The first is that it definitely integrates the most subjects. If you think about the Chem Phys section, it has 30% general chemistry, 25% physics, 25% biochemistry, 15% organic chemistry, and 5% biology. So we're looking at 5 different subjects here. Right? If you compare this, for example, with Psych-Soc, it's only 3 subjects, and for Biochem, it's 4 subjects, but it definitely doesn't have as much integration as in the Chem Phys section. And what's tricky for a lot of students is just the way that science is taught at the university level just doesn't teach students to integrate these concepts, right? If you think about it, after you took general chemistry in your freshman year, how much of that general chemistry content did you have to use for your organic chemistry class the next semester? And the answer is almost none, right? But the problem is that on the MCAT, they will expect students to integrate these subjects together. So as an example, in general chemistry, perhaps the highest yield subject is acid-base chemistry. But acid-base chemistry is not only covered in general chemistry, but it's also in organic chemistry and a biochemistry subject as well. So in general chemistry, you'll learn more of the quantitative aspects of acid-base chemistry. So looking at acid strength and base strengths, and looking at values such as the Ka as well as the pKa. In organic chemistry, you're going to look at how different aspects of the structure of a molecule can affect acidity or basicity. All right, so you'll consider, for example, how induction and resonance can make a compound more acidic or less acidic. So these types of integration are things that students want to try to focus on if they want to achieve a high score in the Chem Phys section. Another reason why the Chem Phys section is tough is because of what I call the luck factor. So the MCAT is a pretty long exam. It covers a lot of content, but if you look at any individual section, you're not looking at a ton of questions, right? The Chem Phys section has 59 questions or 48 questions for those of you taking the shortened version of the exam this summer, but 59 questions, and let's consider physics. 25% physics. That means of the 59 questions you have in the Chem Phys section, you're looking at maybe 12 to 13 or am I doing my math correctly? You're looking at 14 to 15 physics questions, right? 14 to 15 physics questions, and this is based on 2 semesters of physics, right? The first semester being Newtonian mechanics, the second semester being electricity and magnetism. Is it possible for 14 to 15 questions to cover every possible physics concept that you've been tested? And definitely not, right? I can probably just name 14 to 15 physics topics, right? You have kinematics, forces, work, energy, fluids, electrostatics, circuits, mirrors, or optics, waves, sound, and more, right? So because of that, there really is a luck factor on the exam. On your exam, do you happen to get a passage on sound and you get 3 to 4 passages on 3 to 4 questions on waves? Or on your exam, do you get a passage on circuits and you get 3 to 4 questions on different aspects of electrostatics and circuits, right? So for students that are preparing for the Chem Phys section of the exam, sometimes they find that their scores fluctuate a little bit, right? On some practice exams, they do better. On some practice exams, they do worse. In some cases, it's because of this luck factor that they just happen to see a lot of topics that they're strong in, or the opposite, they saw a lot of topics that they aren't strong in. Next, it requires a complex set of reasoning skills. So for any of you who've started seeing the AMC questions, you're going to notice that when you read the MCAT review books, it's not that complicated. You're like, oh, you know, buoyancy, that's like this force that pushes an object up, right? And then you see an AAMC question testing buoyancy, and it's honestly like, what the heck is this, right? Like, how did the AAMC come up with these very impressive questions testing these concepts that are seemingly so simple? All right. So the idea is that it's not just a matter of knowing, oh, buoyant force is this force that pushes up due to a pressure difference in the fluid, but being able to think and reason through the information that's provided to you in the passage and question stem to figure out these questions. So it's not so straightforward as just knowing the content, but the reasoning skills is really quite important. So in terms of skills tested, there's another way that we can break it down, which is, and this is based on the AMC's categorization. So there's 4 skills, which they call skill 1, skill 2, skill 3, and skill 4. Skill 1 is knowledge of scientific concepts and principles. This is essentially, do you know the science content or not? Skill 2 is scientific reasoning and problem solving. So this is where you have to do a little bit of thinking. Skill 3 is about experimental design and research. So in the Chem Phys section, you'll usually have a few passages that's describing experimental setups or some kind of study that was done. This tests a combination of knowledge of basic science lab techniques. For example, do you know the difference between native page, SDS page versus reducing SDS page? Other questions will ask you, what happens if they do this manipulation, right? If they ran the experiment doing this, what would the results be, right? So that's what it's based around in terms of design and execution. And the last skill is data-based and statistical reasoning. So in this case, the AMC is going to present you a figure or a table of some sort, and you're expected to be able to look at that data and be able to come to some kind of conclusion of what exactly the data is saying. All right, and finally, last is math. This is another major reason why a lot of students struggle with the Chem Phys section, and it's just that math takes a lot of time for some students, right? For some students, math can be a little tricky, and this is not just some students. There's actually quite a lot of students who, when they're taking the MCAT, they actually skip all the math questions because they want to get to all the questions first and then come back to the math questions later. Now, that's not necessarily a perfect strategy because there's kind of a number of flaws to that approach, but it is a very real thing that for many students, just because you have calculations, there are equations and constants you have to think of and figure out how to use, this can slow students down. And because of that, a lot of students have pacing issues when it comes to the Chem Phys section. So you can see here, there's really quite a lot of reasons why the Chem Phys section is a very difficult section of the exam. The next thing we want to talk about, obviously, is, well, how exactly can students get a top score in the Chem Phys section? So a number of things for you to keep in mind. Number one, don't let material slip through the cracks, right? So this is what I was saying. The MCAT has a luck factor when it comes to the Chem Phys section. You don't want your test day to be a gamble of, gosh, I hope on test day I don't see anything on circuits, right? So if you want a top score in the Chem Phys section, you should really be prepared for any possible topic that shows up on the exam. So if you know that there's a particular chemistry topic or physics topic that you've never felt comfortable with, then that's a topic you definitely want to make sure that you address at some point. Another thing that's important is, in terms of slip through the cracks, you want to recognize that the MCAT is not a hard exam because of the difficulty of the questions. If you look at any individual question in the Chem Phys section, they're all really fair, right? They're not ridiculous in any capacity. What's tough is the wide breadth of material tested on the exam. So for a lot of students, the challenge is after they've gone through all the content, they just can't retain all of that information. So it's a matter of figuring out, well, what are those topics that you've forgotten, as well as what are those topics that you think you understand, but perhaps don't understand as fully as you need to. So in these cases, it's most helpful for students to have a written record of some sort to be able to gather all of those content topics that you've forgotten at some point, or those content topics you didn't fully understand, and you go back to that written record on a regular basis. And this can be done in a variety of ways. Some students like to do this with an actual physical journal, which is fine, but these days in the digital age, a lot of students prefer spreadsheets of sorts. So that way you can keep a record of all of the questions you're getting wrong and the associated content topics. The next thing is, build your mastery by using active study methods and test your recall regularly. So perhaps the most common study resource that students are going to use for the MCAT, that's a study aid and not just MCAT books or practice questions and so forth, are flashcards, particularly Anki flashcards, right? This is something that's very popular in medical school, and it's sort of transferred to the MCAT, right? And if you're one of those students that spend a lot of time in the online pre-med communities, you'll find these pre-made Anki flashcard decks that have like 10,000 cards and are made by a student who got a 528 on the MCAT. The first thing I'm going to tell you is a lot of students seem to have this idea of, oh, if I use this set of flashcards that this student used and got a 528, I'm going to get a 528 too. The unfortunate news is if you check any of those online pre-med communities, you'll probably realize that none of those students who used those cards with that intention ended up with a 528. There's a couple of things to think about, which is in terms of flashcards, and what I'm saying here is not just like stuff that I'm saying that makes sense, or stuff I'm saying anecdotally, but there's actually proven research on this. People have done research studies on what are the best ways for students to memorize and be able to retain content. And flashcards is a very common tool that students use, but you'll find in most of those research studies that the vast majority of them will say that half or more of what students get out of using flashcards is making the flashcards in the first place. So if you simply just, download Ortho 528, you're essentially already hurting yourself of half of your studies. So it's fine to use flashcards, but definitely make your own flashcards. The other thing for you to think about is how to make your flashcards. So Anki has a variety of different ways that students can use flashcards, and there's a variety of different features, but the way you want to make your flashcards is the way that you're going to be tested on the exam. So for example, Anki has one of these types of cards called close, right? Which honestly is just fill in the blank, right? So it will be something along the lines of an atom with 4 electronic groups and 2 lone pairs will have this electronic structure. All right, and fill in the blanks sounds like it's a nice way for students to memorize content, but the thing is you have to realize that not a single MCAT question is going to be fill in the blank, right? The MCAT is a multiple choice test, but it's not a fill in the blank test, right? Instead, what you're much more likely to see on the exam is some part of the passage, some part of the question stem mentions some kind of keyword, right? So for example, a question might ask you, it might mention something about vasodilation, right? So if it mentions vasodilation, you're going to get multiple answer choices related to vasodilation. Something you want to be able to do is recognize what are you supposed to know about vasodilation from MCAT and what aren't you supposed to know, right? So if you were to do this and have a good card on vasodilation, it would probably have the following. Number one, you do vasodilation to decrease blood pressure. Number two, you do vasodilation in order to bring more blood to the surface of your skin to be able to lose more heat by radiation. You also do vasodilation to in combination with vasoconstriction to deliver blood to different parts of your body. For example, in a fight or flight response, to vasodilate the blood vessels going to your skeletal muscles and vasoconstrict the blood vessels going to your digestive systems. All right, so these are the different things that you want to think of. So that way, if you run into any answer choice that's saying, oh, this person did vasodilation in order to increase the blood flow throughout their body, then you would recognize, well, that sounds reasonable, but that's not something I've actually learned about for the exam and not something I have memorized in association with vasodilation for the MCAT. So therefore, that is an incorrect answer choice, right? So essentially try to avoid those fill in the blank flashcards and just go with the very simple, term on one side and on the back of that card, everything you should know about that concept. Okay, the next, practice early and often because the MCAT requires critical thinking skills, not just content mastery. This is the idea that reviewing science content is important for the MCAT, but it's really a blend of content as well as practice. You can't sacrifice one for the other, right? There's some students who think, oh, if I just do 200 practice questions every day for 3 months, I'm going to get a great MCAT score. But often for those students, the tendency for them is just to miss a bunch of questions over and over and over again, right? For a lot of questions, you have to learn that you have to figure out why you're missing those questions. And if it's just that you're lacking content, you need to spend time and go and review the content, right? At the same time, you can't just do the content and not do the practice because then you won't know how to apply that content. So practice is important, content is just as important. So next, you are unique and your study strategies should be. Simply following strategies other top scorers used is not enough. I hear this all the time, right? And these days we have so many sources to hear from high scoring students, right? Or you see all these posts, for example, on YouTube, you'll find these videos like how I got a 528 on my MCAT, how I got a 99th percentile MCAT score, or you'll see, posts in the online pre-med communities saying how I went from a 502 to a 525, right? And if you just compare one post with another post, you'll see that they say completely different things, right? So for example, some students would say, oh, one thing I did for cars that just changed everything for me was I started previewing the question stems first, right? That I just read the question stems before I read the passage, and that made all the difference for cars. And you'll read someone else that for them, oh, what I did for the cars section was I just gave up trying to take notes, or I gave up trying to highlight. And then you'll find another person who said, oh, the thing that changed the most was I wrote down an outline of the passage, right? So the issue is that you can watch all these videos, but the thing is, if you watch all these videos and read all these posts, you're going to find that there's no consistency, and that's because every student is unique. So you want to find some strategy or some approach that works for you, but at the same time, I'm going to say that for a lot of students, as you go through your studies, it can actually be really frustrating. You put in so much time and effort in your studies and you're not seeing any progress. That might be a good indication to change your approach in some way, shape, or form, right? If something isn't working, really try something out, try something different. And when you try something different, don't expect results immediately. It does take some time to completely shift your way of thinking, but it's at least worth giving it a try. And finally, review practice questions with a focus on recording concrete content and strategy improvements you make next time. So when students are reviewing practice questions, a mistake they make is focusing too much on focusing too much on the answer for this question, right? For example, they might have a question on, they might have a question, what's a good example question? They might have a question on, what type of enzyme is this enzyme described in the passage, right? And then in the passage, essentially, they told you that it was a protease. So a protease is an enzyme that breaks down proteins, and they just make a note. It's like, oh, I need to have memorized that protease is a hydrolase enzyme. And then they don't take note that the other answer choices are isomerase, ligase, and ligase, right? And they focus too much on that, on essentially the correct answer, without realizing that they don't understand the other answer choices either. Another very good example is a question that asks about some form of transfer of genetic information. And let's say your answer choices are conjugation, transformation, transduction, and transfection. A lot of students would just say, oh, this question was asking about introducing new DNA into bacteria from the environment, so that's transformation. They make a note on transformation, but they don't recognize that the other answer choices are based on content that they're supposed to know on the exam too. Right? So you want to make sure when you're reviewing your practice questions, you want to really do your review in such a way that gives you takeaways that's going to be able to give you a lot of improvements on future questions. And that often means your review shouldn't be too narrow, but should focus on everything that the question is trying to cover. All right, so these are some good tips to think about for Chem Phys. The next thing I want to do is just to run through a quick Chem Phys passage. I thought that this might be nice since so far it's been lots of me talking, not so much you guys getting to do a little bit of practice. So let me give all of you 2 minutes to read through this passage, and we'll run through a few questions together. So I will start a timer now. All right, that's time. So let's go ahead and walk through this passage. So kind of my goal here is to read through this passage and present kind of my thoughts as an MCAT expert, right? So in this first paragraph, chloride dismutase is a homotetrameric enzyme that catalyzes the decomposition of chloride into dioxygen and chloride. So a few things that I would note here, and obviously in the exam, you do have a highlighter tool, right? So what I like to highlight is, first of all, chloride dismutase, and this catalyzes the decomposition of chloride into dioxygen and chloride. The reason why I'm highlighting this is because the vast majority of passages in the ChemPhys section will focus on one thing, right? So that means it's going to test you about one enzyme, one compound, or one specific pathway, right? So since it's chloride dismutase and this is what they're starting off with, then you already know that this is what the passage is going to be focusing on. They describe the reaction of chloride decomposing into dioxide and chloride. You may not know what chloride is, but they show it to you in the reaction. So that's great. So next, to produce chloride dismutase for stoichiometric and kinetic analysis. So honestly, this kind of sentence doesn't say anything, right? Chloride dismutase was expressed in E. coli cells. Here, I'm going to highlight this just so you have some idea of what's going on. If they're going through an experimental procedure, a lot of students can get lost. So in a lot of these cases, it's good to read it sentence by sentence and make sure you understand what's happening at each step. So they expressed chloride dismutase in E. coli cells. They used isoelectric focusing, and they found that pure chloride dismutase has an isoelectric point greater than 9.6. And they say that this is significantly higher than most soluble E. coli proteins. And then after lysing the E. coli cells, the cell lysate was passed through an ion exchange column at pH 8.6. So in this case, we're able to figure out step by step what did they do. So they expressed the enzyme, they figured out its isoelectric point, and then they ran it through an ion exchange column, and they collected 70% chloride dismutase in the flow through. Good. So next, a steady state enzyme kinetics analysis was performed on the purified COD. Again, this is an intro sentence that honestly doesn't say anything. Different quantities of chloride was dissolved in potassium phosphate buffered saline, blah, to form solutions with concentrations over a range of 800 to 1500 micromolar. There's a lot of people who will say, oh, you should highlight the numbers, but honestly, I don't find highlighting the numbers helpful. It doesn't really tell you anything. And honestly, when you're looking at a passage, numbers are pretty easy to find. So a catalytic amount of chloride dismutase was added, 5 nanometers, and the initial rate of chloride depletion was measured, figure 1. So when I look at figures, I'm not trying to make any conclusions. I just look at the axes. Oh, x-axis is chloride concentration, y-axis is reaction velocity. Okay, this is a Michaelis-Menten saturation curve. That's it. And then to determine if the products of chloride decomposition inhibits the reaction, the researchers measured the activity of chloride dismutase with varying concentrations of chloride or oxygen. The presence of oxygen did not have any effects, but Kcat and Km of chloride dismutase were decreased with increasing concentrations of chloride. So this thing I'm definitely going to highlight. Kcat and Km are decreased with chloride. The reason why is because the MCAT does like to test about enzyme kinetics, and if they tell you these values Kcat and Km decreased, you have a very good chance of getting a question on one of these things, or if not both. Okay, so this is the passage as you should read through it, and when you're looking at ChemPhys passages, your goal should be to get through the passage in a couple of minutes, right? And that's not unreasonable because ChemPhys passages, they're not like cars passages, so it's not a ton of text. So 2 minutes is very reasonable. So let's go ahead and start with this first question. In reaction 1, how does the oxidation number of chlorine change? So in this case, they're asking about reaction 1, so you know exactly what part of the passage to go to. and they want to know about the oxidation number of chlorine. So this one shouldn't be too bad because we go to reaction 1 and we just need to figure out the oxidation number of chlorine. So I guess maybe to try to get a little interaction here, does anyone want to look at this molecule and tell me perhaps what they think the oxidation number of chlorine is?
3 plus. Oh, good job, Kevin.
3 plus. All right. So in this case, that is absolutely correct. And the way you would figure this out, for those of you who are unsure how we got the +3, is you always look at the elements that are bound to each other and simply ask which element is more electronegative. In this case, oxygen's more electronegative, so it's going to take electrons from chlorine. How many electrons is it going to take? As many as it can to get to noble gas configuration, which in this case would be 2. And chlorine has to give up those electrons. But you also have to remember that the sum of the oxidation numbers has to equal the overall charge of the molecule. So it seems like chlorine would give up 4 electrons, but in this case, it only has to give up 3 in order to get to this -1. Very good. And similarly, who thinks they know the oxidation number of chlorine in the product? Excellent, very fast. So this one's pretty simple, right? If you only have chlorine and that's the only atom, then the oxidation number is going to equal the overall charge of the molecule, -1, very good. So in this case, we can say that the oxidation number went from +3 to -1. So in that case, that will give us as our answer D. Great. So let's look at number 2. Which of the following amino acids most likely contributes to the stabilization of chloride in the active site of chloride dismutase? Again, I'm going to tell you this is very much an MCAT style question. I'm going to tell you for these types of questions, there's actually 2 possible approaches. Anytime they're asking about what amino acids are important for binding in the active site, or what type of intermolecular force is important for that binding, the answer is always based on one of 2 sources. Either the passage text is going to give you some information about, oh, this type of interaction is important, or this amino acid was really important, or they're not going to give you any information. If they don't give you any information, then you have the structure of the molecule provided. So in that case, you're using the structure of the molecule to determine what type of interaction is going to be important. The question I have for all of you is, what if you have both? If they give you information, the passage text that tells you what type of interaction is important, and they give you the structure of the molecule, which one wins? Which one do you think you should follow? And if you don't know, you can at least guess, right? It's 50-50. Do you go with the passage text or do you go with the figure?
Passage text?
Passage text is correct. All right, does not matter what the figure looks like. And the AMC has done this, right? Where you have this molecule that looks largely nonpolar and there's like one tiny polar part, but if the passage text tells you that it's an important, an acidic residue is important for the stabilization in the active site, you absolutely go with the passage text. Very good. So then let's go back to this passage. If we look at the passage, there was no mention anywhere at all of how the binding works. So in this case, we simply look at the structure of chloride. And looking at the structure of chloride, what type of amino acid do you think you would be looking for to bind it in the active site?
+1.
That's correct. And a +1 is what type of amino acid? Acidic, basic, polar, or nonpolar? Basic, that is correct, right? So in this case, you just need to know histidine, arginine, or lysine. And in this case, we have arginine, so that is indeed correct. Phenylalanine and valine are nonpolar, and glutamate is acidic. Very good. Let's go to number 3. Which of the following correctly describes the chromatography used to purify chloride dismutase? All right, so this was definitely referenced in the passage, right, where they said that they used the ion exchange chromatography to isolate the chloride dismutase in the flow through. Now, if you look at your answer choices, it's kind of split between two different ideas. It's either going to be normal phase ion exchange chromatography or reverse phase ion exchange chromatography. And separately, it's either cation exchange chromatography or anion exchange chromatography. Let's try to tackle this first part, normal phase versus reverse phase. How would you know whether they're using normal phase or reverse phase ion exchange chromatography? Any ideas? Or a question we can maybe ask before this is, what exactly is normal phase versus reverse phase ion exchange chromatography, all right? All right, so in this case, the difference between normal phase versus reverse phase is based, so yes, it is true. It's polar versus nonpolar, but the thing is, both normal phase and reverse phase chromatography has polar versus nonpolar. The distinction is which one is used as the stationary phase and which one is used as the mobile phase. So in normal in normal chromatography, and we'll use S for stationary and M for mobile. The stationary phase, this is just like thin layer chromatography, right? So your stationary phase is going to be polar and your mobile phase is going to be nonpolar. In reverse phase HPLC, it's simply the opposite, where your stationary phase is going to be nonpolar and your mobile phase is going to be polar. It might seem like there's not much of a distinction because in either case, you're doing a separation based on polarity, right? Whatever interacts more strongly with the stationary phase moves less, and whatever interacts more strongly with the mobile phase moves more quickly. But the key distinction that you want to focus on the MCAT when they ask about this is, what types of molecules are you trying to separate? Are you trying to separate nonpolar molecules, or are we separating polar molecules? So in this case, if we're trying to separate chloride dismutase, what type of molecules are we working with, polar or nonpolar? Any guess here? Polar is correct, right? Essentially, all enzymes and proteins are going to be polar. So if this is polar, then it has to be a reverse phase HPLC because polar compounds cannot dissolve in a non-polar solvent. That's actually kind of the true power of reverse phase HPLC. While both types are able to separate compounds by polarity, reverse phase HPLC allows you to use this separation techniques on various biological macromolecules. And that's because all of the biological macromolecules, except for fats, cannot dissolve in a nonpolar solvent. Very good. So that allows us to start off by eliminating A versus C. So we're between B versus D, which is anion exchange versus cation exchange chromatography. So to distinguish between these two, we need to know a little bit more about how the separation worked. So what they tell us is that the cell lysate was passed through an ion exchange column at a pH of 8.6, and the flow through was found to be 70% chloride dismutase. Couple of things. Number one, anytime you run an ion exchange column, something's going to get stuck in the column, something's going to pass through. In this case, what we're looking for is what passes through. So that means this is not something that gets stuck in the column. So between cation exchange chromatography versus anion exchange chromatography, cation will trap cations. Anion will trap anion. So we simply have to know, in this case, our chloride dismutase at a pH of 8.6, is it going to be positive or negative? Anyone have any ideas? Will the chloride dismutase be positively charged or negatively charged? Positively charged is correct, right? In this case, something to keep in mind is knowing how pH compares with pI. When the pH is less than the pI, your molecule is going to be positively charged. When the pH is equal to the pI, your molecule is going to be negatively charged. When the pH is equal to the pI, your molecule is going to be neutral. So in this case, since we know the pH is less than the isoelectric point, our molecule is going to be positively charged. If it's positively charged and it flows through the column, that means your column cannot be trapping cations. Therefore, it has to be anion exchange chromatography. And that allows us to select answer choice B. All right, number 4, what is the Km in micromolars for chloride dismutase? It's probably the easiest question in this passage. So in this case, Km, you should all know, is simply defined as the substrate concentration at which the reaction velocity is equal to 1/2 the maximum reaction velocity. We simply just have to go to the data presented in the passage. We have to look for the Vmax, which is probably around here. And then we look for half of that value, that would be 1/2 Vmax, and we look at the Km, which looks like it's maybe around 200 micromolar. So if we're looking at 200 micromolar, well, we just need something that matches that. 200 micromolar, and since they're working in scientific notation, this would be about 2 times 10 to the 2 micromolar, which is closest to answer choice D. All right, we have one last question. This last question is, which Lineweaver-Burke plot most accurately depicts the kinetic data of chloride dismutase with and without the addition of chloride? All right, so the first thing we need to know here is exactly how do Lineweaver-Burke plots work? All right, the thing I'm going to tell you to focus on are the intercepts. So who can tell me when we're doing Lineweaver-Burke plots what the x-intercepts and y-intercepts refer to? X-intercept and y-intercept. Perfect. So I believe Kevin is the one taking it in August, so it's good that he's giving these responses. So x-intercept, indeed, -1/km, and y-intercept, 1/Vmax. So when we're looking at these Lineweaver-Burke plots, you're going to have some graph with the enzyme alone, and you're going to have a separate graph with the addition of a compound. This is typically to look for the effects of inhibitors. Now, if you look at these different graphs, you'll see in some cases the x and y-intercept both changes. In some cases, only the y-intercept changes. In another case, only the x-intercept changes. That's just trying to get you to figure out what type of inhibitor that you're working with. So if we go to the passage, we need some information about either the type of inhibitor we're working with, or we need some information about the Km or the Vmax in the presence of chloride. Now, we did highlight this portion, which told us that the Km decreases, right? So that's pretty straightforward. We know what happens to Km, but do we have any information here about Vmax? And if so, where is that information coming from? Kcat, very good. So what's the relationship between Kcat and Vmax? There's a particular equation you want to know here. You are very close, but you have it arranged incorrectly. I swear there has to be an MCAT test prep book out there that has the equation wrong, because what you've told me is what I hear from so many students. It's VMAT is equal to Kcat times the total enzyme concentration, right? And this makes sense if you think about what the definitions of these terms are. So E total, of course, is the total enzyme concentration. Kcat is the turnover number. It's the fastest that an enzyme can produce products, right? So for some enzymes, it might be, pretty slow, one product every 3 seconds. For other enzymes, they're super fast. They can produce 10,000 products per second, right? And you definitely don't have to apologize, because for this question, you still would have gotten it right. But it's still good to make sure you know the right one just to be safe. So Kcat is the turnover number of an individual enzyme. If you want to know what is your maximum reaction velocity, that depends on 2 things. Number 1, how fast is your enzyme? And number 2, how many enzymes do you have, right? Because if you look at the original equation written, if you solve for Vmax, you have Vmax equals Kcat over enzyme concentration. And that sounds a little suspicious and quite odd to say that increasing enzyme concentration would decrease the Vmax, right? So in this case, since they told us that Kcat decreases, if Kcat decreases, then Vmax also decreases. So in this case, we have Vmax and Kcat both decreasing, and we have a very nice question, which is it normal that I am lost and have no idea about the questions? It is completely normal. The reason why is because this is a biochemistry passage, and biochemistry is usually taken as a sequence. You'll take general chemistry, you'll take organic chemistry, and then you'll take biochemistry. So I wouldn't worry too much of this at this point, because it's probably because you haven't taken the class yet. It might be possible that, if you've taken general chemistry, then the first question should be okay, but every other question here, you'll likely learn once you take biochemistry. All right, so going back here, we know that the Km decreases and the Vmax decreases. Since both of them are denominators, that's going to give you a larger value. So 1 over Vmax, 1 over a smaller value gives you a bigger value. So that means what we're expecting here is for the y-intercept to move up. So if we want the y-intercept to move up, then we can hold on to A for now, because we can see the y-intercept move up. We can get rid of C because the y-intercept actually moved down. We can hold on to B because, actually no, we can get rid of B too, because this y-intercept moved down. And if we look at D, the y-intercept did move up. So we're between A and D. But then the last part is Vmax. Last part is Km. You're dividing by the Km. The Km gets smaller, so you have a bigger value. But you have a negative sign, so it's a bigger negative value, which means you expect the x-intercept to move to the left, which matches A, and not D, because in this case, the x-intercept doesn't move. Okay. So hopefully that was helpful for those of you, especially those of you who are looking to take the MCAT soon. And just some things to think about when you're going through a passage that you can see for the MCAT. It's really a combination of you need to know the science concepts, but you also need to be able to read a passage, extract the relevant information, and apply your knowledge of science to that passage information. So the last thing that I wanted to touch on today is kind of this super cool mobile application that we just released last month. It's called MCAT Prep by MedSchoolCoach. You can find it on your phone by going to the Apple App Store or the Google Play Store. The app is 100% free, and if you download the app, you're going to find that it has hundreds and hundreds and hundreds of MCAT videos covering science content tested on the exam. In addition, each video is associated with a set of flashcards and a set of practice questions. So that way, after you review the video, after you watch the video, you can actually test yourself. Do I understand the contents covered in the videos? There's also a study schedule that's built in. So that way, if you're trying to plan out, your studies, you can just say, oh, let me set this 60-day schedule. So every day I have X number of videos to watch to make sure I can get through this. The other thing that is important to note is that this app is completely free. So it's something we definitely encourage all of you guys to at least check out, especially those of you who are going to be doing your MCAT preparation soon. It's a very convenient way to be able to study on the go. Okay, so that is it for the presentation that I had set up today. If any of you have any questions, please feel free to enter them into the chat box and I'll be happy to answer any questions that you might have about the exam.
So I have one question about the car section. And so I think of myself kind of as a slow reader usually. And so the car section kind of stresses me out a little bit. Are there materials out there that have articles and passages or books that are recommended that are kind of similar in reading level or content that you might see on the card section? If that makes sense.
Yeah, so there's a few things here. I guess I kind of think of it as two separate questions. The first question is sort of, pacing is a concern. The second thing is trying to do more reading that's similar to CARS text. So to address the first question, I hear this from students all the time, which is they feel like the reason why they do poorly in the CARS section is a pacing issue, right? One thing to think about is try to figure out if that is the only issue or if there are additional issues, right? So for example, a lot of students often say, oh, I do a CARS practice test, and because I have to rush, I end up getting this low score that I'm not happy with. And they think, oh, if I had more time in the CARS section, I would get a much higher score. So for these students, the first thing I ask them to do is do a set of 3 passages untimed. Right, on time. Give yourself unlimited time on these passages. If you need, give yourself an hour for each passage, right? The reason why I think this is important to do is you want to see what your accuracy is without any time constraints. So if you don't have any time constraints and your accuracy still isn't where it needs to be, then pacing is not something I would be worried at all at this point, right? Because there's more important things that you have to sort out of making sure that you're able to extract the central thesis of the passage, as well as maybe understand the reasoning behind the questions on the exam. If that's not an issue, meaning that if you do a set of passages on time and you're getting an accuracy at the level that you want for your desired CAR score, then there's other things to focus on, right? One of these things could be to try to increase your reading pace, but it is a little tricky because you want to make sure that you aren't sacrificing passage comprehension, and that results in a lower score. But if you're looking for more sources to improve your CARS reading, there is a number of sources that you can use for this. And we actually have a PDF document that has a full list of links. Because I know a few off the top of my head, but I don't know all of them. So I don't know if perhaps Alexi, who is with us today, is able to find that link and put it in the chat box, because I think it'd be very helpful. If we can't find it now, we'll send an email to you guys and you can send it out to everyone. But in terms of reading, there's a variety of websites where you can find text at that level. So that's definitely very helpful. There was one of you who mentioned Jack Weston. Jack Weston is definitely very popular among the non-AMC questions. And something that's nice about Jack Weston, as well as UWorld, which is probably the other source that's the most popular among pre-med students these days, is that they show you the percentages of each answer choice that other students picked, right? And the reason why this is important is because Jack Wesson has pretty good CARS passages and questions, but about 20 to 30% of their questions and passages are just not good, right? Where when they wrote it, they just didn't do as good quality control. And you can often tell when you see a question where the correct answer only 20% of students picked, and 40% of students picked another choice, and 30% picked another choice, right? In that case, it's probably just a bad question. So that's a good source for practice, but make sure you're able to do a little bit of filtering.
All right. Thank you so much.
Not a problem. I can see here, when should you take the MCAT? So in terms of when you should take the MCAT, it just depends on when is a convenient time for yourself. So I would say there are two main things to consider. Number one, plan out your coursework to make sure that you're able to take all, or if not all, most of the MCAT prerequisite courses before your exam. And the other thing to think about is just when are you going to have a good block of time to be able to focus on the MCAT. So for a lot of students, they'll take the MCAT over the summer when they have a couple of months that they can study full time. Other students, they'll study during the semester and they'll take the exam at the end of the semester. So for example, a lot of students will study for the MCAT over the fall semester, and then they will cram over winter break and take it in January. Or students will study over the spring semester and then take it in May or June before applying to medical school. So those are the main two things I would think about.
I have a question if no one else has one.
Go for it.
So Chem Phys is my weakest section, and I haven't had a lot of like exposure to physics. So when it comes to the time where like I don't recall an equation, I kind of just take a look at the units that they provide in the answer choice and the units that they provide in the question, and I kind of just try to cancel out units. Is this an effective like strategy, do you think, or should I actually like invest more time into studying for this section versus just polishing up my other sections?
Well, I guess the first thing is, how are you scoring right now in this section?
So I've been scoring, so the lowest I've scored like recently is a 126, and I think the highest was a 129.
Okay, and your other sections are all, I guess, 128 plus?
Yeah.
Yeah, in that case, I would put more focus in the Chem Phys section. The reason why is just because getting a high score is nice, but a balanced score is better, right? So I'd much rather you get a 127 in Chem Phys and 128s in the other three sections, which that would give you a total of, what is that? A 511 compared to if you get 130 in the other three sections and a 125 in Chem Phys, right? Unbalanced scores don't reflect very well in medical schools. And you can tell this pretty clearly when you look at the MSAR medical school admissions requirements, that if you look at their 10th to 90th percentile score range, it's generally pretty consistent in all four sections. The only section that tends to be a little lower is the CARS section, but in this case, you're looking at Chem Phys. So I would say definitely put in more focus there. In terms of the strategy you're describing, which a lot of test prep companies will call unit analysis, it works for a few questions, but it doesn't work for all questions, right? There's definitely a good number of questions where all of the answer choices have the same exact units. But in some cases, it is perfectly viable and can help you sort of figure out how to combine the different units to get there. The thing that you want to be careful, though, is that there's a good number of passages where they provide multiple instances of the same value, right? So there might be a passage where they say is that there's a 12-volt battery and this capacitor charged up to 3 volts. In that case, without an understanding of sort of how the voltage of a battery and the voltage of the capacitor are working in the circuit, then you might run into an issue of not knowing which value you should be using. So I would certainly encourage you to try to spend a little bit more time trying to make sure that you understand the different equations. One thing that's actually kind of convenient is, if you've been doing the AMC practice materials, you'll actually notice that most of the physics questions will give you the equations that you need. So they're often pretty generous with that. But if you're aiming for a higher score, then you just want to make sure you have a good understanding of the equations. So that way it's not just a strict plug and chug, but you're able to understand things like, if I have an equation with these variables, understanding why does changing this variable affect the other.
Okay, thank you.
Right, and we have another question of, how does the CAR section compare to the verbal section of the standardized test? So there's definitely some similarity in terms that these sections of the standardized exams don't test any knowledge of science content. That's the similarity. But most people will tell you that, if you thought SAT, ACT, verbal reasoning / reading was hard, MCAT CARS is even harder. Right? That being said, there is a general pattern, which is a lot of students who do well in those sections of the SAT and ACT generally also do well in the MCAT CARS section. So if you're in that situation, there's a good chance that you don't have to do much to prep for the section. However, if those were tough sections for you in high school, then there's a good chance that you're going to have to put in more work into the CARS section. Some things I'll tell you of some of the more subtle differences between the high school exams versus the MCAT is that the high school exams tend to have more of these targeted detail questions where they refer to some specific quote or parts of the passage. And because of that, you can often get away in those high school exams without really understanding the passage and being able to get a lot of the questions right. The MCAT has some of those questions, but they tend to have more of these theme-based questions where you have to be able to understand the main argument of the passage. You have to be able to follow the author's argument from paragraph to paragraph and also be able to understand the author's tone. So that's why for a lot of students, when they're doing MCAT CARS practice, they'll find a lot of cases where if they read a passage and they don't understand the passage, they'll bomb it and miss a bunch of questions. Right? So for a lot of students, when it comes to CARS, it is really helpful for them to try to focus on making sure they can read high level text and still be able to understand what the passage is discussing. All right, so I think that about covers the questions we have, and we're also over a few minutes. So of course, thanks everyone for staying until the end. Of course, if you have any additional questions about anything related to MCAT, you're more than welcome to email us at info@medschoolcoach.com. And Alexi also put in a post in the chat box too. If anyone's looking for a little bit of extra help, you can certainly feel free to sign up for a free consultation to learn more about how MedSchoolCoach helps students with the MCAT. And finally, I also want to just mention again, we do have the free mobile application. So definitely check that out. And otherwise, thank you everyone for joining us.